Hey, welcome everybody. Just wanted to show you this, just put this thing together. This is basically a pulse generator, and you can have variable pulse width or variable frequency depending on how it's adjusted, on off switch. And the whole thing's in a cardboard box wrapped in aluminum tape. The aluminum tape helps to insulate the sensitive electronics inside the box from any high voltages around it. And then it's basically a fiber optic coupler. So this is a IFE96E, that blue thing, IFE96E connectorless, which is the best type. They're easy to connect up. A fiber optic transmitter. And then on the other end of the coil, I've put a receiver. I've hooked this thing in, and I've connected this to that hex inverter, to pin 5. The output of this goes to pin 5 on the hex inverter, and then pin 6 then goes to the MOSFET drivers. So I've got two positions I can toggle it. I can run it off the 555 chip in here, which will give you different types of sparks depending on how it's adjusted. Or you can run it off the fiber optic cable and through this signal generator. So that's what I want to show you today. Let me show you the inside of it. There's two 555 chips. One runs in astable mode, the other one runs in monostable mode, so it enables you to adjust frequency or pulse width or both at the same time. With a little LED indicator light, as you can see there. And this is a very common setup. This one's based on the circuit from Steve Ward's website. I've changed some of the components, as you can see there. Got rid of the burst mode circuit, burst mode enable circuit, and I changed some of the values on some of those components, as you can see there. And then the output, instead of just connecting it directly to the Tesla coil, what I've done is put a 150 ohm resistor, and then I'm connecting it to this fiber optic transmitter, this IFE96E fiber optic transmitter. And you can cut the cable however long you want it. I just made a short little length of it just for testing purposes only, and then I can increase the length later. But you can basically just cut it with like a knife. You can cut it with a razor blade. Make sure that it's as flat as possible so that it sits directly against the transmitter or receiver lens. So let's close this thing up, and then we're going to test it out. I've already turned the logic part of the circuit on, so you can see those two blue lights running. I'm going to put it so that it will work off the fiber optic input. We're going to connect this up, and we're going to see what happens. Okay, just connected it up. Just basically poke the fiber optic cable right in the end there. The other one's poked right in here, and we'll switch it on and see what happens. Here's our Tesla coil. We've got the base of the secondary grounded to the pipe in the ground, and we'll turn up the voltage and see what happens. So it's running on 48 volts. There's the output. Fairly good output for just 48 volts. Now we're going to change the frequency using this optically coupled device. So decreasing the frequency, increasing the frequency. Now we'll try messing with the pulse width. Going to increase the pulse width. That's decreasing it. Oh, that's actually increasing it, sorry. This is decreasing it. Decreasing the frequency. Now we're going to run it in continuous wave mode by just taking the end of this fiber optic cable, just shining light directly into it. So let's do that next. So what I'm going to do is I'm going to hold this right on that indicator light and see what happens. And there you go. Runs it in continuous wave mode when I shine the light into it. So it's successful, and this test piece of cable seems to work really well to run it in both continuous wave mode as well as in pulsed mode with different pulse widths and with different frequencies. So thanks for watching. The next step is to try putting some MIDI signals to get music out of this thing.